Hello, welcome back everyone to Maki Academy. Today we're going to attempt to do one more example on Mohr circle, but this time around we're going to use 3D Mohr circle. It is similar to the one that we have before, two-dimensional, but we're going to see in the angle of three-dimensional. So I'm going to give one example to illustrate that. We're going to see on the Mohr circles. This time around we're going to have more than one circle, all right, for each plane, which is xy, xz and yz, right? So 3 planes for three-dimensional system. But the example that I'm going to give is just, I'm going to start with this, the one that we know for stress element, looking at isometric diagram like this, right? We have x, y-axis and z-axis. Of course, for each I'm going to represent on this direction. For x direction, this is 90 megapascal, sigma y, and also the shear stress. I'm going to put an arrow, right, representing the shear stress with the value of 60 megapascal. Sigma z, there's no arrow because I'm going to write it down over here, given sigma x equals to 90 megapascal. Take that as 90. Sigma z equals to 0 megapascal, and tau xz on xz plane equals to 60 megapascal as written down in the figure. And what you're going to do is to find all values. This is the question actually, of sigma y, for which tau max is equals to 80 megapascal. That is the condition given, right? So we have this question. So plan what we need to do in order to solve this question. First of all, you're going to recognize the stresses given, list it down, and establish their coordinate system, and go ahead and draw, and of course to draw a circle we need 2 points. So for this example, we can pretty much predict that the formula will be useful, of course, because we are not going to use the graph paper. So even though for this example I created the drawing on the graph paper, you can have a look at these the exact drawing for the circles. So looking at this question, we have in all directions we have three-dimensional now. So the purpose of this example is to show you actually a circle in Mohr on a Cartesian chart for the Mohr circle is representing a plane. It's representing a plane for that particular axis. The plane representing 2 axes. X, Y means that you got to the plane for x and y. It is a surface on x and y. So we looking at this question, we can straight away calculate the right, the values that we have here, the sigma average. Right, or perhaps it is good for me to recall the sigma x plus sigma y over 2, and the r, the formula for r, the radius, sigma x minus sigma y over 2 square plus tau xy square, and the value of square root of this is your radius for the circle. So but we do not have sigma y. The sigma y is what we are looking for, right? This is the value that the question is asking us. So to find all values, it suggests that we have multiple conditions, but it is good to go ahead to compute whatever we have for our system right here. So sigma 1, principal stresses 1 and 2 equals to sigma average. This is how we rearrange our equation on the left, and 1 and 2 represent the maximum, minimum, major stress and minor stress, maximum shear stress is equals to sigma max minus sigma min over 2. This is the maximum in plane, maximum in plane shear stress. Talking about the three-dimensional Mohr circle, we do have another what we call as a absolute maximum. So looking at the absolute maximum, when we have a system of probably you are given sigma x, sigma y, sigma z is equal to 0, so you're going to have another probably bigger circle can be developed out of your Cartesian chart, and that bigger state, the largest radius is your absolute, they call it as a absolute maximum, which is the absolute, the most, the largest radius on your Mohr circle. So we haven't done on the, I think it is good to go ahead and calculate on this by using the values. First of all, I'm going to calculate sigma average for this system. Sigma average is equals to sigma x plus sigma z, because that is the one that we are given, equal to divided by 2. And by using this value, of course, you have 90 plus 0 over 2, right? I got 45 megapascal over here. And straight away, quickly, for sigma average, we have done that, and the radius, right? So 90 minus 0 over 2, right? Plug and check the values in the subsequent places, right? Square root of this, and you compute, you're going to have over here 25 megapascal. So we have, what do we have now? 45 degree for sigma average. The radius already calculated over here. But yeah, don't forget, it was given the condition over there for which tau maximum is equals to 80 megapascal. You can imagine this. This is the second example, the third example for Mohr circle. You can pretty much imagine on your Mohr circle there will be a something like this radius over here going to be equals to 80 megapascal instead of 75, right? The radius that you have calculated from the values given, it requires you to, obviously we need a larger circle. All right, so that is the conclusion that we going to have on our Mohr circle. I'm going to prepare some space for the Mohr circle, but I'm going to jot down a few notes over here, right? So you have your R equals to 75 megapascal, right? Right, tau max, this is the tau max on X, but we want what we wanted, right? Tau max to match this condition of 80 megapascal. So I'm going to write it down over here, saying that obviously we need a larger circle, right? Slightly larger than 75, which is R equals to 80 megapascal, right? For, of course, this XY plane. All right, I'm talking about plane right now, so you're going to see that on Mohr circle afterwards. But we're going to do some assumptions over here because there are two, right? Sigma 1 and sigma 2, right? The principal stresses. Is there anywhere that, yeah, okay, right here, right? Maximum and minimum. So sigma 1 equals to 45 plus 75. This is one of the condition, right? Saying that major stress for the system is 120 megapascal. If we said that sigma max equals to sigma A, I'm going to do this assumption. We set that sigma A, and sigma 2 will be 45 minus 75 equals to negative 30 megapascal for and in this case sigma mean equals to we set that as a sigma B, right? This line, two lines over here, is just the completion of our calculation by taking into account sigma averages and the radius, and we do the calculation, the values that we have, 120 and negative 30. So assumptions need to be made, otherwise, like say we set sigma A as our sigma max, right? Thus sigma mean going to be adjusted accordingly. Sigma max minus 2r, because there is the radius for our circle is going to be constructed out of that. So the maximum we have is 120 megapascal minus 2 of the condition that we are given, so it will give you negative 40 megapascal, right? The sigma mean for our case, if we set sigma A as our maximum on our system, of course we can change that. I think it is clearer when we draw the circle, but bear with me. We set sigma B equals to sigma mean. If sigma B we set as a minimum, thus sigma max going to be adjusted accordingly. Sigma mean plus 2 of the radius, which is negative 30, the one that we have from our calculation just now, right? Negative 30 plus 2 of the largest radius that we have, 80, right? Equals to 130 megapascal, right? So let that the last two lines hopefully you can absorb that, right? I'm going to use the first one. I'm going to say sigma A is the maximum. Sigma max equal to sigma A, which is 120 is the maximum for this system. Of course, you need to assume, and the question is asking all values of sigma y. So by taking that into account, we're going to draw, right? So our circle, we're going to start with for our system. So and as well as the 1, 2, 3, right? Right. Hopefully, that could be the I'm going to say this is sigma max. Sorry. This is positive sigma. This is our positive shear stress. I'm going to set right, this is 120, this is 60, 120, 60, and this is 30, and this is 90, right? So as well as the it's going to 30, 60, 90, right? 80 around here. So 30, 60, 90. So we need to plot this to create a proper circle. So I'm going to jot down a few points over here, which is very important. This point, for example, this point over here, this is 120 megapascal for the maximum, right? 120 0 for this point over here, and we also have the circle that we're going to have the first average sigma average is around 45. This is 30. Right, 30, 40, 50, 60. So 45 is around here, right? 45 is around that point over there. So I'm going to this is sigma average, right? 45 megapascal for sigma average, right? Then also last but not least, right, negative 30, right? Negative 30. So a few points that we I'm going to take. So first of all, to visualize that what we have for the first instance over here, the value for sigma average, we got that for 45 megapascal, right? And we out of that we can calculate to draw our circle. This is 45 megapascal, 75 is around, right? I need to make some correction over here. So this is 60, 70, 80 and 90. So 75, right, it's about that point over there. So remember, this is just the sketches for our solution over here. We pretty much have the answer, right, from our calculation. So I'm going to draw out of this is 45 megapascal, the sigma average that we have. So we have the circle out of this point, right? Hope. Yep. Need to be careful with that, because the circle is going to go through that. So remember, this is 75. This length over here, this is 75 megapascal, because out of our calculation we have our radius. But the condition given, we need to have a slightly larger circle, because the condition given to us is R equal to 80, the maximum shear stress. So we need to adjust that. This is where these two calculations being made. I'm going to set sigma A as a sigma max, right? Sigma A is sigma max. This is my maximum. So we need to create another circle, but and it will end up at negative 40 as the point on the negative side of the normal stress. So negative 40, 40, 50, so going to stop around here, negative 40 megapascal. And what happened to the when you calculate to we're going to have the new sigma average, which is 120, right? 120 plus 40, 160, and divided by 2, right? So the middle is 80 megapascal from 120, so you need to deduct that 120 deducted by 80, your new sigma average. All right, your new sigma average will be over here 40 megapascal for the new sigma average, right? So out of that center point, we need sigma average for our center of our circle. So remember, keep that in mind. So 80 is around slightly larger, right? As well as this is 75 and this is 80, right? Slightly larger, 80 megapascal, right? So go ahead and draw. So your new Mohr circle going to look like more or less like that, right? So it's going to merge at 120. So I'm going to label them out. So we have the first circle in red. This is our XZ plane. Why XZ plane? Because it was given to us tau XZ and sigma X and sigma Z. So similar to the previous Mohr circle that we have before, the representation of that plane is now changing to XZ, and what we are looking for is XY plane, because this is the condition given to us, which is the tau max now given for us is 80 megapascal, the condition given to us. So it is good to label out from this diagram over here. This is XY plane, and last but not least, this is your, I'm going to put it in green, that is possible, right? So this is your YZ plane, right? It's got three planes for our three-dimensional system, right? So have we answered the question? They are asking for sigma y, for which tau max is equal to 80 megapascal. So we have for XY plane, remember this XY plane, the maximum for XY is 120, and the minimum, the least that we can have for our sigma y will be negative 40 megapascal. That answers the question for this particular one. But remember, we got another condition. Probably I'm going to finish up with this simplified diagram, right? In order to complete the second assumption that we have. If I'm choosing sigma b as the sigma mean, right? So if negative 30 was selected, so I'm going to draw, of course, the 120 and 120, right? Just a simplified circle I'm going to create out of this, right? Hopefully that looks circle enough, right? So I'm going to label this 120. Probably it's going to mess around. This is 120 megapascal. This is negative 30, which is sigma mean in our calculation. Now by using the same which is we already compute, right? We already computed that 130 megapascal is the new maximum when you say sigma b negative 30 is your minimum. So the circle going to be shifted. We need a larger ones, and it's going to be shifted like so. We're going to end at 130 megapascal. So this is the sketch, right? I'm going to label this out. This is 130 megapascal, and this is negative 30 megapascal for sigma and shear stress. So you're going to have a new again, this is XZ plane, this is XY plane, and this is in green, this the YZ plane as shown in this on the top diagram. All right, so because we assume in this example sigma b is equal to sigma mean, and our circle going to be shifted to the right. So either answer is going to be correct, but in this example we have a look on the property of Mohr circle, right? Where we can have the properties of the Mohr circle in three dimensional can be visualized properly in the side by side according to the circles. I think it is also useful to point out in this. I'm going to show we recap this in the previous example. The properties of our Mohr circle. So we have our in the beginning we have our sigma average is 45. So out of this we can create simply the location of our Mohr circle is located at. From there we can we need to have 2 points, remember, to draw the Mohr circle, and out of this we have the information given from the question. Sigma x 90 megapascal, right? 90 megapascal, and the tau maximum for x-set plane is 60, somewhere around here. So obviously my drawing is not drawn to the scale, but I would like to point out that this line here, if you draw it properly on graph paper, you're going to hit sigma z equals to 0, right? And this should be 60 according to the scale. If you draw it properly, this is negative 30, right? This is negative 60. So it is useful, the usefulness of the Mohr circle. When you need to remember the formula, then only you can have the x-set, and by sketching it we're going to get a good idea of our stress element drawn on the Mohr circle. We can say this is a point where we have 90, 60. I'm going to say this is point A, and the 180 degree to that line is your point B, which is exactly the one that you have 0 megapascal for sigma z, right? The coordinate, if you like, 0 and negative 60 is our point B. So vice versa for the other planes also. So we are pretty much going around the property of Mohr circle, but I would like to show you another. This is credit to Wikipedia, right? This is an example for Mohr circle. If you notice that they are using a slightly different, positive for normal stress to the right, but upward for positive shear stress. So everything going to be on the left side, right here. The diagram is showing the Mohr circle on 360 degree, and this part right here, the stress element drawn for each, right, point A, B, C. So A, B, C, D is each and every element diagram is drawn for you on the right side. So to understand this, I think it is important to sigma average, the typical point where your center point is located. R is your radius, which is from this is your the radius of the circle. What else? A and B, right? A and B is opposite on each other, if you like, sigma x, right? Sigma x for A direction, B is sigma y. Probably slightly different from the 3 examples I've given to you, but it is pretty much 180 degree from A is your B point, 180 degree to your A is your B, the point B, which is consists of coordinates of normal stress and shear stress. Right. What else? The most important point on probably for this example, I hope you can probably search it on Wikipedia and have a look and try to digest that. And yes, sigma 1, sigma 2 for principal stresses. Each and every point on this circle we can draw the stress element, but it is not necessarily need to be done for all of the points, because only the points asked in the question, critical points if you like, the principal stresses, major and minor. And probably we can say this is for xy plane, the Mohr circle for xy plane. Let's say for this system sigma z is equal to 0. I'm going to say this is another point for sigma z is equal to 0 for this case, right? So perhaps the circle, all right, for this example right here, 0 is located over there. Obviously for this system, there is no question given for this diagram right here, but I would like to show if we can say the largest circle over here is the previously in the previous page I mentioned that we have the R right here is representing the maximum in plane shear stress, right? The shear stress in plane, the maximum point of that, this is equivalent to R. And if we have the absolute, given that sigma z is equal to 0, so from this point here to point here, you need to calculate the middle, the center point for our larger circle, and this is what we call as our tau absolute maximum. What is the difference between absolute maximum versus tau, the maximum in plane shear stress for the circle, right? We have both of the values could be asked by the question, right? So bear that in mind. Tau maximum in plane, right? Maximum in plane. So because obviously from the name, that for that plane that is the maximum, but for this system, if you are given the number for sigma x, sigma y, and sigma z, right? So absolute max is this the new, if you like, that the new radius, which is the largest radius for the circle, going to be absolutely, obviously the absolute maximum for the system. So I think that's all for this three-dimensional Mohr circle. It is pretty much the same with the previous two-dimensional, but by using the knowledge from there, we can strengthen the understanding for Mohr circle. So I'm going to stop here for this example. Take it easy. Thank you very much and goodbye.